Now, can you see that?
Yes, now I see it.
Okay.
And the size is fine, by the way, I can read it.
Okay, good, good, good. Okay, I will talk about this, some examples for applications. Yeah. And first of all, I will mention some good practices, yes, when you're using a HPC resource like Kebnekaise. And this can be applicable also to other resources in Sweden. Yeah. So first of all, this was mentioned by Birgitte previously. Use your project directory, right, instead of your home directory, because this the size of the home
I lost the
directory
sound.
is not good.
It is very low, but I don't know.
Let
I
me
can hear well.
Now it got
oh,
fine again. It
let
might
me
have
let
been
me
mine because it's normal again now.
okay, now it's
Uh,
better.
for me it's slightly muted, but I can hear it.
Okay, now
It's good for me.
okay. So okay, let me know if you cannot hear me. Mhm. Okay, so this was mentioned by Birgitte, yeah, and use your project directory instead of your home directory because the home directory has a limited storage space, right? And this ones the project directory has a larger space, but also pay attention to this is not backup. Yeah. So you need to put the important data for long term in some storage space that you commonly use or you are comfortable with to storage a long-term data. The second thing is very convenient, right? And this is something that I usually do is create a soft link to the storage project. And this was covered by Birgitte. I remember as far as I remember. Yeah. And why is that? Because in this case, the name of the project directory will be available in your home directory uh, directly, right? So instead of typing every time the long name for the project directory, if you choose some name, in this case I choose name, right? This is the name that I gave. Then I create a subdirectory. Then the next time, this will be present as a shortcut, yes, to this long name, right? So this is very convenient, at least in my case, because I don't need to type this long line. The next thing is the monitoring of the resources usage. And it was also mentioned by Birgitte. So you can use on the command line the job usage command and then give as an input the job ID that you get when you submit the job with SBatch. Then you will get a URL. And if the program takes more than 3-4 minutes, let's say, then you will see the statistics when you paste the URL in your local browser. So if it is too fast, let's say 1 second, then you won't see any statistics in this place, yeah? In the web browser. So this is quite convenient in even more when you are running your code in an HPC center, because as you have seen in the batch script, you can request many cores, many nodes, many GPUs. But imagine that you request 10 GPUs and you forgot to load the proper module for running CUDA, yes, or some machine learning code that employs the CUDA, yeah. So in that case, even though you request 10 GPUs, you won't use anything in this. You won't see anything here in the GPU part. Or this is one thing, and the other is that maybe you request 100 cores, right? And you forgot to load some module, or you are not running the code with MPI run or SR run, and then you will end up using only one core, yes? So your project will waste some core hours and GPU hours, and even though it doesn't cost anything in terms of the money, it's also using some energy, right? And also maybe that can be some resource useful for other users. So pay attention to this, especially when you are running parallel codes in HPC resources. So we have this tool at HPC2N usage where you can monitor your jobs by yourself instead of telling us to monitor that. So this is one suggestion that I found useful, yes. And this is when you have some issues with your software or with your scripts, something is not working well, or you have some questions. Then the best thing is that you write to this address, right? support@hpc2n.umu.se. And in this way, you will create a ticket that will allow us to track the issue. So this is useful, convenient, because we change the person in the support every week, yeah. And then if you are writing to one specific person, right, and your ticket is not solved or your question is not solved, then it can land on between the chairs, let's say. Yeah? So this is a way for us to keep track of the issue until the solution is found or some convenient solution is found, right? So these are some practices that you can apply when you write a ticket. So you can describe the problem and the versions of the software that you use. Yeah. Then we can provide us with a test case, right? That we can copy so that we can try it ourselves and see, reproduce the error and give you some useful feedback. Because otherwise, if we only read that there is a problem with the software or with your workflow, then we don't know what to do. It's like when we go to the doctor and we don't, the doctor cannot make an analysis, right, of the part of the body that is causing pain. So in that case, we can see and get our hands into the problem, right? So this is convenient, but if you cannot share the real case, then you can maybe create a toy example, right? That has still the issue, but uh, but it's not the real case and it's not the big model, let's say. Imagine that you are running a machine learning model that takes several days, right? And instead of that, if it is a more localized issue, then you can try something reduced, right? And provide us with the folder containing all the relevant files. Otherwise, if you cannot share the scripts and it's not possible for some reason, but then you can describe the best you can the problem so that we can give you a good feedback. So this is useful if you already open a ticket, use the ticket to discuss only the issue with this ticket right? And instead of creating different tickets for the same issue, so we can use the same ticket. For unrelated issues, open new tickets, and this is good practice as well, right? And if you consider that the error is solved, then you can let us know, yes, that this is already solved. You are running your programs well, right? And it's providing you the correct result so that we can close the ticket because otherwise we don't know when to close the ticket. Maybe it passes some months and after some time the user returns and we already solved the ticket and there is another person in charge of the support or the person is not working any longer. So there are several things, right? So well, the point is if you consider that the ticket is solved, then you can let us know and we can close that. So this can keep us the ticket system clean. Okay, these are some good practices from my side. Yes, when you use an HPC resource. And now my question to you is if you have any preference for the programs that you want to see. Yes, I have some examples for programs like MATLAB. I have R, AlphaFold. Let me see, CryoSpark, and several Nextflow. Let me see, Upchainer, TensorFlow, Jupyter Notebooks. So, is there any preference from your side? Because otherwise, maybe you will waste your time if you hear some software that you won't use at all. So, do you have any preference?
I would like to hear about Jupyter Notebooks.
Okay, yes, let me see. Good. Okay, so this was mentioned by Brigitte briefly, right? And currently, I would say currently, we have a workflow at HPC2N where you submit the jobs to the queue. I will show you how to do this. And but we will have, yes, and we are already working on a more flexible workflow, and I think Birgitte mentioned that, which is called Open on Demand. And this will allow you to use Jupyter Labs by using your web browser. So that will be very convenient. But because we are experimenting with the Open on Demand, yes, at this point, I will show you how to use that with the existing setup, right? So next time, I hope we can give a more extensive uh, example for Open on Demand. So here you can see here there are several versions for Jupyter Lab that are installed as modules on Kebnekaise. And so notice that there are different types of nodes, also mentioned by Birgitte. There are the Intel nodes and also the AMD nodes, right? And these ones contain different types of GPUs. So Kebnekaise is highly heterogeneous, right? Which is convenient for a user because sometimes you want some specific hardware, but at the same time, you need to read this part and also, yes, be aware of the type of hardware that you will request, right? So for instance, one of the things regarding Jupyter Labs is that there are more versions available on the Intel nodes than on the AMD nodes. And this is because these ones are older and many people were asking for different Jupyter Lab versions and they were installed over the years. But here, because they are newer, the AMD, then there are, of course, less Jupyter versions there. Yeah. So here are some guidelines for using Jupyter notebooks on Kebnekaise. I will go to this link. So this is more extensive, right? And you can see here that one can use a batch script, right? And here there are some guidelines for installing your own packages. So I will cover this part. So let me go to this first, I call it exercise because you can try it yourself. Yeah. So, and here is you running a simple Jupyter notebook. This can be convenient if you are in the phase of developing your code and you want to display some graphics, for instance. Yeah? So here you can prepare your batch job, your batch script, and this is here. Yeah? So if you go to this script, you can see how it looks like. So you see the previous uh, options that Brigitte covered, your project ID. Will ask for one core, right? And here you ask for 10 minutes for the job. And here you are asking for the type of GPUs. In this case is L40s, right? And you will ask for one GPU card. So notice that here I am using this more than one dash. Yes, more than one of these symbols. Hashtag, yes, it's not dash, hashtag. So which means that this part is commented. Yes. So this will be seen as a comment by Slurm. But if I eliminate these two, then this will be an instruction. And in this case, I will be requesting one GPU. This is what I mentioned previously, that if you are not uh, aware of the different lines in the batch job, then you can think that you are using something when you are not using that at all. Yeah. So you can see here this how this example looks like. This is a purging line which avoids writing extra information in the output files, right? So then here you see the modules that are required for Jupyter Lab, and this is the version that will be used and that is available on this type of GPUs, right? And then here we start the Jupyter Lab. This is the line for starting Jupyter Lab dash dash no browser dash dash IP, and this line we throw the name of the host. So let me try this. Let me minimize this thing here. So I can go to my Jupyter and simple. You can see that I have already this script here. So I can change my project ID to the one for this course, HTC to N 2025 014. Yeah. And then I will uncomment this part. And also, I will try that without the reservation, but if it takes a long time, then I will use the reservation. I hope this is not confusing, but I am using a different editor, which is called VIM, and this is more powerful than the Nano. It allows you to do many more things, yeah. But it's also a bit more complex to deal the first time that you try the editor, yeah? So I have this script, and what we do now is that we submit the job to the queue. Then you can see here this job ID, and then I can type the job SQ dash dash me, and you can see that it is running. Yeah, this is the type of the GPUs that are being used, or the partition. Sorry, the partition. My username. This is the job ID. This is the name of the node, and this is the time that it has been running. So then I can check the content of the directory, and I can see this Slurm output file. So if I go and see the content with more, right, then I can see this output, yeah. And at some point, yes, in the file, I will see a line starting with this line here, for instance. HTTP VCN, so I copy this, I copy this line complete together with the so-called the token. This a series of numbers and letters, right? I copy this, then I go to my local browser in my machine, then I paste and go. Yeah. Oh no, no, sorry. No, this is not correct. So I cannot do it. So the local browser, by the local browser, I meant in the thin link session, right? I go to menu, yeah. Then I go to internet, yeah, in the thin link client. Internet, then go to Firefox, yeah. And then here I paste and go. Yeah. And this, what I tried before, I was confused because this option is not available for Kebnekaise. You cannot see or you cannot load the Jupyter session in your browser, in your laptop or PC. This is available only if you are already on Kebnekaise. I see this here. Yeah. So here I will dismiss this message, and you can see here that I am in the Jupyter session, so it is running. So these are the different environments that I created previously, so I can activate them if I loaded the modules. And these are the files that are available in the current directory, and you can start using your Jupyter Lab. So is there any question about this? How to get this up to this point? So you can write that if you don't want to be recorded. So I can read this. No, I cannot see any question. And then you can see here that the Jupyter notebook is running, right? So we can check another thing here. I will try SQ dash dash me. You can see that the notebook has been running for 4 minutes. So then I can type this command job usage and then the ID. So I got the URL, and this one I can take this one for job usage. I can take and paste that in my local browser. That is valid. Yeah. But the one for Jupyter notebooks need to be here on the theme link session. So you can see the usage of the resources. Nothing has been used for the GPUs because I haven't run anything. Also here, the CPUs only 0.3% of one core that I requested. There are also some metrics for the memory, the temporary directory, the system, the Lustre system, yeah. And you can see here how much you are using for your simulation, but nothing for the present one. Yeah? So, okay, so now I can close this Jupyter notebook here. So I close that, but it doesn't mean that I terminated the Jupyter session, because if you type again SQ, you will see that it is still running. Yeah. So I can go and cancel the job if I don't want it, yes, any longer. So now it's not there. Yeah. So this is also important. Imagine that you requested 7 days for your Jupyter notebook, and you just close that and think that it stopped working, but it is still running in the queue and using some using your allocated resources. Yeah. So here there are other more elaborated examples for the Jupyter notebook. This is one application developed at Umeå University. It's very interesting for detection of community networks, network communities. And this application is called InfoMap. This is more specific. Here there are some guidelines to do the PIP installation, right? For this particular software, and also using Jupyter Lab. Notice that if you load Jupyter Lab, you already get some Python version that you can then use to you do the PIP installation of your software. That will be compatible with this Jupyter Lab, and then you can visualize your results and so on. You work in a more interactive manner. This is one example for a CPU and GPU for some Julia set. Yeah. And then you can try this. Yes, and here you will use a CUDA and together, yes, with the NumPy, Matplotlib, and QPy. So here are some instructions. You can try that. And also this is a more specific maybe, but it's also possible. One can use MATLAB inside a Jupyter notebook. Yeah. So one can install a particular kernel, in this case a MATLAB kernel, so that you get MATLAB running inside your Jupyter notebook. This can be useful if you need some MATLAB functions, yes, and also if you want to do some machine learning, deep learning with functions that are available in MATLAB or in some Python libraries like TensorFlow. It can be also possible. And here are the guidelines that you can follow. Yeah. Is there any question about these Jupyter notebooks? Something else you want to know? Okay, so if you have other questions, then you can ask in the document. Let me see. There is no other question. Okay. So okay, yes. So let's now go to the next software. It's another software that you want to hear about.
Yes, I would like to hear about R.
Okay, R. Let me see. Where is my R? R. Okay. Now I will move to my folder R, where I have several examples. This is in the intro course exercises, and then the name of the software. In the present case is R. R, yes, similar to MATLAB or the web browser Firefox that I show you, is available through the menu bar, which means that if you go to Thin Link and go to menu, then you can go to programming, for instance, and then choose this RStudio plus R. Yeah? However, there are several things that I don't like from this setup. Yeah, it could be there could be more reasons for using that, but I prefer to load R in a different manner. Yeah, and why is that? That's because if I load that, if I just click on this, then I will get R Studio plus a default version of R. Yeah, not the one that I am targeting. So instead of doing this, yes, so on choosing this option here, what I do is the following. I will do a purging here in case I loaded something, but I didn't load anything. Yeah. So what I will do is the following. I do a module spider. This is a shortcut for module spider, and there are capital. Yeah. So, and here you can see the different versions that are available, and similar to what I said previously, if you are in the Intel login node, which is this one that I am using, yeah, you will see several versions of R. But if you go to the AMND node, login node, which is what Brigitte did with SSH, and then Kebnekaise dash AMD. If you do this, then you will do an SSH to this login node, and then you will see other versions of R and less, most likely less versions, right? Because these nodes are newer. So I am in the Intel and I can see these different versions. So what can we do? So we can explore the version that I want to use. And then I can do LML spider, this version, right? This is the one that I choose, but you can choose anything, any one, any other. Yeah? And it tells me that I need to load the following modules before loading R dash 4.4.1. Yeah? So then I need to load this one. And after this, I can load the R version. Yeah. Okay. So now the first time that you try one version of R in particular, let's say this one, 4.4.1, yeah, you need to configure your environment, your settings by going to this preparations step. Yeah. And this here, there are the different steps that you need to follow. Let me do a zoom in. So here, first of all, you can follow these steps. And here, you see here that R reads this file, which is in home, and it's called .r environ. So for instance, I am here in the project directory. I will move to my home directory, and then I will check if they have this project, this R environment file. Yeah, and you can see that I already have this file. So, and this is needed because R reads the content of this file. So you need to follow these steps here. Here, the number 3. So you type echo or just copy this file, copy, and then go to your the terminal, then paste, right? And this will instruct, yes, the echo command to send this output to the environment, to the R environ file for the present version of R, which is 4.4.1. Yeah? And then this environment variable will be available as this one here, R underscore libs user, and this will be read by R in this way. Yeah. So this will be useful when you install programs that are needed by R, in particular when you install the packages. Yeah? So in this way, you will tell R, please write or don't download and install the packages for specific versions in this folder here. And this folder will be read in the R environment file. So notice here that you need to create also this folder, right? In particular, they mentioned here the R version 3.6.0, but if you're using the version 4.4.1, then you need to change that accordingly. Yeah. So here there is a simple example that allows you to install a package from the crun repository, right? And here you can follow the steps. So and at some point you will see that there is a mirror list, yes, that you can choose, and there is one option for Umeå University that is convenient and is relatively fast with respect to the other. This is a more specific example. For instance, if you have some code, right, and then you want to perform the installation by yourself manually, right? So this is also possible. So, okay, please, you can follow these instructions if you want to install your own packages and to avoid the R to write to some default, yes, a path that you cannot control in the way you want. So, okay, I will return to my folder. So this is the first thing that you need to do in R, the preparations step. And here there is a recommendation, and this is something also common in HPC environments, especially when one is using a parallel programs. No? Yeah. You can incur in data duplication. And I have seen this in cases for machine learning and deep learning scripts. Yeah. So this is one particular example. Yeah. There is a function called MC apply that is used in several scripts. Yes, when you're trying to parallelize some expensive function, then you think that this function will do a nice job and clean job. But if you are not aware of what you are doing, then you can incur in data duplication. And if the size of your data is not large, right, then it should be okay. But if your data, imagine that your data is 20 gigabytes, yes, 20 gigabytes, and you use a MC apply with 20 cores where some function is parallelized. Then at this time, because the data can be duplicated, you can end up with 20 times 20, which is 500 gigabytes. And the standard nodes only contain up to 190 gigabytes. Yeah. And then you will see that there is your program crashed, and it's not easy to see from the first time what's happening. Yeah. So this is one example that illustrate this issue. So we call this parallel PRIR packages. PRIR will allow you to see the size of the objects. Yes, not exact, but this is an indication of the size, right? Yeah. And here, for instance, you can see I print out the memory that is allocated just at the beginning of the script. Then I create some data frame at this point, right? With some entries for input values here. One is called ID and the other value. Then I do a function where I take the data frame that is defined here, the data frame, and I use some index, yeah, called I in this case. So then inside this function, I do some modification, yes, of the data frame. And just modify this, return this, and then after this process, I print out the memory, right? And this could be a serial execution. Yeah? Because why serial? Because this is just a function that is doing some computation. So no problem up to this point. This is a serial mode. This is one core. You can use a one core only, no problem. So but now imagine that this is a large data frame and you want to parallelize this function so that each iteration is solved with the MC apply, which uses some parallel layer. Yeah? So in particular here, I will use 4 cores. Then I will do the iteration over the rows of the data frame and use this function in parallel mode. Yes. And then you immediately will see that the memory increases. Yeah. And now why is that? Because now you are using 4 cores and MC apply tends to duplicate or replicate the data. Yeah. Then one good exercise that is that you can try this script. You can call it, for instance, mem duplication .r, and then you can submit the job with this script here. Yeah, that is here, and you can see how the memory is used, especially with the job usage command. Then you can see how the memory was used at this point, and then you will see that the memory is increased upon using the MC apply with 4 cores. Yeah. So we need to be aware of this situation. Previously, I mentioned that one needs to take care of the number of CPUs, but especially for data expensive codes like R or machine learning, deep learning, this situation can occur. Also, notice here that I loaded already this R version. Yeah. So I previously said that I prefer to load R Studio on my terminal, and I can do this if I type here R Studio. Yeah. So now you can see that I got my R Studio. I will ignore this because I cannot update this script myself. Yeah. The R Studio version, it needs to be done by the administrators. And here you can see that I have a R Studio. I can start working as in my laptop, for instance. I can open a new file, do some uh, coding, right? And notice here that once I have the script, I can create one, for instance, one R script. Yes. So I can do library parallel, for instance. And here I have the option similar to to the PC or the laptop, Windows, Mac, right? Where I can run the code that is written here. But if I do this, I will be running the code on the login node. Yeah. And this can interfere with the workflow of the other users. And that's why if the code here is lightweight, maybe you can do some plots that are displayed here in this part of RStudio. Yeah. So that's okay. But imagine I write a parallel job with 20 cores. I run this, then all the users will see a delay in the performance of the login node. And where we have had previously the experience that we had to go to the login node and manually restart that because it's simply unresponsible. Yeah, unresponsible. Yeah? So so this can happen, especially for parallel jobs with R or Python or MATLAB or anything. So that's why we ask you to run only lightweight stuff here on the login node. And RStudio can be used for editing files and yes, creating files and doing some lightweight plotting. So here there are some exercises that you can try. So these are the requirements. And this is the R version that I suggested here. And we need to install the packages with R. There are different ways to install the packages. First of all, we can go to RStudio, for instance, and here in packages, you check if some package that you need, yeah, is already there. For instance, we can check for AR MPI, and we can see that is not here. Yeah, so it means that I would need to install it. I can also try do parallel. Is not there as well. Maybe Caret, a framework for machine learning, is not there. Mass, some data structures, no. So you can see that most of them are not here. So what I usually do is that I install the packages. Maybe this is too small. Let me see. But at this point, I don't exactly remember how to increase the font size. Can you see the text here in RStudio? Because I think it's too small. Yeah? Zoom in here. Yes, zoom in. Yeah. So what I usually do, yes, and you can do in another way. Yeah? But here I do install packages, and then I select, for instance, do parallel. Or let me see something less expensive. I will try do parallel. So then you can see that it's installing, yeah. And if you set the the folder with R environment, then you will instruct R to install the packages in that particular folder. So this is one way to install it inside R, and I like that because I can see the messages in a cleaner way. Yeah. Otherwise, just start R on the terminal here, and then do R the install packages stuff. So okay, then I can show you this exercise. Yes. And here there is a serial job, yeah, serial job only, which means it will use only one core. So here, this is the folder or the job that is provided. So this is a script called serial .r, and it simply prints out the hello world string and then some variables. Yes. Here for the arguments, and then print out the argument. Let me see how I am in the time with the time. Let me see. Where is my here? Okay, we have now coffee break, and then we are returning at 15. Yes. So then here is example for the job submission script. As you can see here, there are the parameters that were mentioned previously by Birgitte. So notice here that I am using a constraint to use the Sky Lake nodes. And why is this the case? Is it the case? This is because for this R version, yes, this R version can be found on these nodes, right? So, but imagine that you check in both the Intel Skylake and the AMD nodes, and you find that the R version is compiled or is available, the same version with the same compilers. Yes, these lines here, GCC, OpenMPI, for instance. So if it is both in the AMD and the Skylake nodes, then there is no reason to use any constraint, right? So the problem is if the version is available only in one of the nodes, then you can instruct Slurm to look only for those nodes that contain the version. So otherwise you will see a message, error message saying that ARC couldn't be found, or there were some errors, yes? So yes, I use the Skylake for this part, for this version. As here I show you two things, two ways to run R, right? That sometimes is confusing for the users. Here there is one way to run R by using the RCMD badge, right? And the name of the script. So if you run R in this way, yeah, you won't be able to use the command line arguments, which means that in this script here, you won't be able to see these lines here, the content of these arguments, because this way for running R doesn't accept command line arguments. If you need command line arguments, then you can use R script instead of this manner. So there's a confusion in from the users, right? They don't know which one is the best. So the purpose is different. So this is better, I would say, well, because you can introduce command lines arguments. So in this case, if you run R in this way with R script, then you will be able to print out the value of 3.14. Otherwise, with this one, not. Yeah. That is one feature from our script that yes makes it very useful. So then you can submit the job, right, and monitor the script, right? So the next thing or the next exercise that you can try is by using job arrays. Yeah. So here there is a simple example that could be very complex in real situations, right? But this I'm using just a single parameter, right? Imagine that you have some experiment or you want to do some simulation where you change the value of the temperature that goes from 2 Celsius to 56 Celsius, right? And you want to run 28 simulations where only this parameter changes, right? So this could be more complex because imagine that you don't have one single parameter, but you have many. And in that way, you can still find or yes, you could find some way to tweak your script to use a similar approach as I'm doing here. So here I will use the task ID to control the value of the parameter temperature from 2 to 26, say 56, and run 28 simulations, yes, simultaneously. Yeah. So how to do that? So this is an example. I will close this one. And here you can see what I'm doing. So here I am getting some environment variable that is thrown by Slurm. And in this case, I am using an array of jobs or a job array, right? And this will give me some environment variable, right? Then I will print out this variable, and in Slurm, there is also an environment variable for the task ID. So when you submit the job on or a job array, you will get a job ID for the entire task, but also you will get something more coarse grain, right? Which is the task ID, and this is an identifier for each task in the bigger job ID. So this is the big task, and these are the individual tasks that are launched by Slurm. So in this way, I can tweak the job so that each of these get some temperature. For instance, I can use these values, yes, that goes from 0 to 27, let's say, and use this variable to compute the temperature that goes from 2 to 56. And the job, Slurm job, looks like this, right? So these are the common parameters that we saw previously: the time, the project, the constraint for the Sky Lake, the output error files. And the important part is here with the dash dash array. And here I specify the number of tasks that goes from 1 to 28. Yeah. So this instruction would allow me to get the task Slurm array task ID, and this is an environment variable. So in total, I will get this variable task ID from 1 to 28. Yeah. And I can tweak this to get the temperature from 2 to 56. So that's why I mentioned that this is a simple example with one parameter, but you can tweak that somehow to get different types of parameters, right? And how to run the script, you can have this script, you call script arrays, which is this one. And here I am just printed out the names of the values of the variables. And here you can place the rest of your code, right? For the temperature in this case. So this workflow is very convenient if you want to write or to run different simulations where one parameter or several parameters are changes, right? In an structured manner, let's say. And this is a simplistic, yes. Another thing that you can try is that instead of using these variables to tweak the parameter you're interested in this case, the temperature, what you can do is to write some list of input files. Let's say, imagine that I have some files for different parameters. Let's say a parameter A, which has a value 1.0, then B, which has a value 0.5, 5, C, 0.8, let's say this, and then I can save this file. I will call that simulation1.txt, for instance. Then imagine I have this input file for the first simulation. Then I have another file. Let me see another file. New file. Text file. Yes, sorry. I have another file where the parameters are changed. I have here 1.9, for instance. And I can have many files, right? I am choosing only 2 in this case. So, but notice that the difference is the values of the parameters, yes? And imagine that I have 20,000 input files. Then what I can do is to create another file that can be called, for instance, save, and I will call it list of files.txt. Then I can write here simulation1.txt, simulation2.txt, and so on until simulation 20,000.txt. Yeah, and I can tweak. Yeah, I can tweak this script, but this is a bit more complicated, right? It's possible I can tweak this script, this Slurm, to run the 20,000 task by reading these files here, whose content is like this. Yeah? So this is another way to run the job arrays. You can see that this quite flexible. Yeah. One way by tweaking the parameters with some variables. and the other by writing some list of files and then tweaking this script. But it's more complicated, I would say. Yeah, but it's possible. Okay, this is a more specific example for RMPI. Do parallel. Here you can see how to run some machine learning job and explore the resources usage. And this is more about machine learning. Yeah. Is there any questions about this part? Something that is not clear or nothing was clear?
No, it was clear, thanks.
Okay, yeah. So you can try these scripts, and yes, I hope that they can help you somehow. Otherwise, you can write in the document or ask us. Yeah. Yeah. I hope it's useful. And this is a killer. This job arrays, I would say, especially if you have many parameters. I will recommend that. Yeah. So this is a simple example, I would say. Okay, I read that some person